Hello everyone, welcome back to the video lecture of digital logic. So we are discussing the computation method. That means in our last video we have already discussed the binary addition and the binary subtraction. So actually we are discussing the computer arithmetic, and we have four basic arithmetic operators like addition, subtraction, multiplication and division. So in the last video we have the basic concept of binary subtraction. That means by taking a borrow from the left column, we are using to subtract a number from another number. But that is actually efficient way when we are performing the subtraction in pen and paper. But when we want to implement the subtraction in terms of computational method, there we have another efficient way, that is the additive method of subtraction. So I am saying that additive method of subtraction. So that is actually surprising. We are using the additive method for subtracting a number from another number. So that additive method is also known as the complementary method of subtraction. So today class we are going to discuss the complementary method of subtraction. So before going to know what is the complementary method of subtraction, let's first know how to complement a number or how to find out the complement of a given number. The given number may be decimal, may be hexa, may be octal or may be binary. So let's see how to compute the complement of a given number. Suppose the given number is 45. Here 45 is of base 10. That means 45 is a decimal number. So what is the base here? The base is 10. So the method for calculating the complement of a given number, that is base to the power n minus 1 minus that number. So this is the method for finding out the complement of a given number. So here what is the n here? The n is the number of digits. So how many digits are there? There are 2 digits, 4 and 5. So here n equals to what? 2, because there are 2 number of digits. Then we have to find out the base here. So what is the base? The base is 10. And what is the number? The number is what? 45. So how to calculate the complement of 45? That is base 10 to the power n. So 10 to the power 2 minus 1 minus the number is what? 45. So this is what? 100 minus 1 minus 45. 99 minus 45. So that is 54. So this is 54 in base 10. So 54 is the complement of 45. Like that, suppose I am taking the 45 as a octal number. So what will be the complement of 45? That is in octal. So here the base is what? 8. 8 to the power 2, that means there are 2 number of digits. So 8 to the power 2 minus 1. So that is 64 minus 1. So what is that? 63. This one minus 45. So this is 18. So 18 is in base 10. So now we have to convert this 18 into octal, because the question is given in octal base. 45, that is base 8. Now here we are getting the result as 18, that is a decimal. That means here the base is 10. Now we need to convert this base 10 into base 8. I know you people have already practiced how to convert the base 10 into another base. So 18 base 10 will converted into base 8, and what we will get the result, that will be treated as the complement of 45. Suppose another question is 10101 base 2. Now we have to find out the complement of this number. So here n is what? N is 5. There are 5 number of digits. So base raised to the power n, 2 to the power 5 minus 1. So that is 32 minus 1. What we will get? We will get 31 base 10. Now we need to convert 31 into binary, because after getting this we have to subtract this from this. So this is of binary and this is of decimal. So we need to convert this into binary. So what is the binary for 31? If I will go for the column position like 1, 2, 4, 8, 16. What is the binary for 31? 16 plus 8, that is 24, 24 plus 4, that is 28, 28 plus 2, that is 30, plus 1, that is 31. So all column positions should be 1. So this is equivalent of 31. So this is a base 2. Now we have to subtract this from this. So 1, 0, 1, 0, 1. 1 minus 1, that is 0. 1 minus 0, that is 1. 1 minus 1, that is 0. 1 minus 0, that is 1. And 1 minus 1, that is 0. So this is the complement of this. So another method is there where we can find the complement of any given binary number without using the complementary method. So how to complement a binary number? Here simply we need to transfer each and every 1 into 0 and each and every 0 into 1. That means we are complementing each digit. 1 will convert it into 0, 0 will convert it into 1. In the place of 1 we have to write the 0, in the place of 0 we have to write the 1. And after writing or after replacing 1 with 0 and 0 with 1, what we will get, that is the complement of that given number. Simple. So here what is the number? 10101. We need to replace 1 with 0 and 0 with 1. So here is the 1. So I need to write here a 0. Here is the 0. So here I can write a 1. Here is the 1. So I can write it as 0. Now the 0. So I can write it as 1. And now 1. So I can write it 0. This is simple. We need to convert 1 into 0 and 0 into 1 for each and every digit. So what we will get? This is the complement of 10101. Now you can compare here. 0, 1, 0, 1, 0, 0, 1, 0, 1, 0. You can go for the complementing and subtracting the number, or you can simply change the 1 into 0 and 0 into 1. So this is how we can convert or we can calculate the complement of a given number. Let's see how to calculate or how to compute the subtraction by using the additive method or the complementary method. The step 1 is compute the complement of subtrahend. So what is the subtrahend here? Suppose I want to subtract 5 from 12. So here 5 is the subtrahend and 12 is the munand. So here 5 is the subtrahend and 12 is the munand. Next, in the step 2, add this result to the munand. In the step 1, we need to complement the subtrahend. We have to find out what is the complement of the subtrahend. That means this. If I want to subtract 5 from 12, then first I will go for complementing the 5. What is the complement of 5? Then after getting the complement of 5, I will go for adding that complement to the munand. So the step 2 is add this result or complement to the munand. So the step 3 is, in the step 2 we are going for addition. So in case of addition we have two options. Either we will have a carry or we will not have a carry. So there are two options. So what will happen if we have some carry and what will happen if we have no carry? So there are two options. So if there is a carry, then add this carry to the result. So here, after adding the munand and the complement of the subtrahend, if we have a carry, then we are omitting that carry, or we are taking this carry and we are adding this carry into the result that we got from the complement and munand addition. If there is no carry, else if there is a carry, then we will go for adding that carry to the result. If there is no carry, then we will go for the else part, recomplement the result, and put a negative symbol or negative sign. So this is actually simple. In the first case, we have to find out the complement of the subtrahend. Then what we got the complement of the subtrahend, that we need to add with the munand. Then after getting the result, if we have some carry, then we will go for taking that carry and adding that carry at the right side. If we have no carry, then what we got the result by adding the munand and the complement of the subtrahend, we have to recomplement that. So after recomplementing that result, we have to put a negative symbol. Why we need this? Why there will be carry and there will be no carry? Why we have to put a negative symbol? Suppose there are actually two methods. There are actually two possibilities. Either actually we are doing what? Munand minus your subtrahend. If the munand is greatest and the subtrahend is smallest, then we will get a positive result. The munand is greatest and the subtrahend is what? Smallest. We have to subtract a smallest number from a largest number. So obvious the result will be positive. That is the case where we got a carry by adding the munand with the complement. But what will happen if I want to subtract a greatest number from a smallest number? Obviously we will get a negative. Suppose I want to subtract 5 from 12. So what will be the result? The result is 7. So this is what? Positive. But I want to subtract 12 from 5. So what will be the result? Here 5 is the smallest number, 12 is the largest number. So what we will get? Minus 7. So that is negative. So in this case where we got the positive result, there must be a carry with the addition operation. But when we got the negative result, there must be no carry. So we need to recomplement that. You will better understand when we will take some example. So the first question is subtract 56 base 10 from 92 base 10. So we want to subtract 56 base 10 from 92. That means 92 minus 56. So what is the subtrahend here? This is the subtrahend and 92 is the munand. So what is the first step? The first step is find out the complement of the subtrahend. So what is the subtrahend here? 56. So in the step 1, we need to find out the complement of 56. So how to find out the complement of 56? There is the base, that is 10. To the power the number of digits, there are 2 digits, so 10 to the power 2 minus 1 minus 56. 56. So 100 minus 1, that is 99 minus 56. So what is that? 43. 43 base 10. Next, in the step 2, we need to add this result with the munand. So what is that? 43 base 10 plus 92 base 10. So what will be the result? Here is the 43 and 92. So 3 plus 2, that is 5. 9 plus 4, that is 3 with the carry 1. So that carry will come to where? We have to take this carry and we have to add this carry with the result. So 1 will get added here. This is the step 3. So what is now? 36. So this is the result. This is the first case where we got the carry. So what will be the result actually? 2 minus 6. So we will take a borrow from here. So 12 minus 6, that is 6. Here is what? 8. 8 minus 5, that is 3. So here is the 36 actually. The 36 and 36. So this is the additive or complementary method. First we will go for complementing the 56. There we got 43 as the complement of 56. Then we will add that complement with the minend, that is 43 plus 92. So what we will get? 3 plus 2, that is 5. 4 plus 9, that is 13. So actually the result is 3 and with carry 1. So here we got a carry. So when we got a carry, then we need to keep that carry and we have to add that carry with the result. So there we got the result as 36. So let's see where we don't have a carry. Okay, subtract 32 base 10 from 18 base 10. So here is the subtrahend, here is the munend. Now subtrahend is actually greatest than the munend. So in the first step, we need to complement 32. So how to complement 32? That is 10 to the power 2 minus 1 minus 32. So that is 99 minus 32. So what is that? 67 base 10. So 67 base 10 is the complement of 32. In the step 2, we need to add 67 with what? 18. 67, where we got the 67? This is the 67. And where we got the 18? 18 is the munend. So now add this. 7 plus 8, that is 15 with carry 1. 6 plus 1, 7 plus 1, that is 8. 85. We have a carry? No, we don't have a carry. So when we have no carry, then what will happen? We will go for recomplementing that. So we will go for recomplementing 85. So in the step 3, recomplement 85 base 10. So how to recomplement? That's in the same procedure. 10 to the power 2 minus 1 minus 85. So 99 minus 85, that is 14. So now we have to put a negative symbol here, because we know that when we have no carry, then we have to recomplement the result and put a negative symbol. So that's why we are putting a negative symbol here. If we will go for the basic method, that is 18 minus 32, then also we get minus 14 as the result. So this is the complementary method of binary subtraction. So let's see, this is actually decimal subtraction. So let's take an example and have a binary subtraction by using the complementary method. Subtract 0, 1, 1, 1, 0 from, this is actually in binary, from 1, 0, 1, 0, 1. This is also binary. So this is the subtrahend and this is the munend. So in the step 1, what we have to do? We have to complement this one. So this is the number 0, 1, 1, 1, 0. So what is the complement of this number? We have to replace 0 with 1 and 1 with 0. So 1, 0, 0, 0, 1. Then in the step 2, this is the actually complement. In the step 2, we have to add this with this. So 1, 0, 1, 0, 1. Let's add this. 1 plus 1, 0 with carry 1. 1 plus 0, that is 1. 0 plus 1, that is 1. 0 plus 0, that is 0. 1 plus 1. So 1 plus 1 is 0 with a carry 1. So when we got a carry, then we have to take this and we have to add here. So we will take the carry from here to here. So 0 plus 1, 1, 1, 1, 0, 0. So let's convert this into decimal. Okay, so what is the number here? We need to subtract this 10101 minus 0110. So if it is 1, 2, 4, 8 and 16, so what is this? 8 plus 4, that is 12, plus 2, that is 14. And what is this? 16, 8, 4, 2, 1. So here is 16 plus 4, 20 plus 1, that is 21. So 21 minus 14, answer will be 7. So here, what is this? If it is 1, 2, 4, 8, 16, so 4 plus 2 plus 1, 6 and 7. So this is 7. So this is right and this is right. So each and every time when we have asked for subtracting a binary number, after doing the calculation, we need to recheck by converting them into decimal. If these two answers will be matched, that means our operation of subtraction is correct. Otherwise, we need to rework on that. So I hope now you people are clear how to subtract a binary number from another binary number. You can use the borrow method, that means that is actually easiest method. But when we need to implement the subtraction into some digital component, there we need to make the subtraction easier way, and that is what we have the complementary method of subtraction. By using the additive or the complementary method of subtraction, that will be quite easy. I hope you people got some basic knowledge about the addition and subtraction. Do practice, take your own number and try to subtract them by using the additive method. In our next class, we will go for binary multiplication and division. Have a great time. Thank you.